Alright, let's take a look at our review, and we'll pick off where we left off at number 15. Number 15 is a limit as x approaches negative infinity. So we can't use our bigger on bottom, bigger on top rules because, or Betsy rules, because it's not x raised to some numerical power here. It's 2 raised to the x power. So with that difference in mind, we're going to try to, first thing we'll try to do is directly substitute and see if that helps us. So we can't use those. So at the top we have 5 plus 2 to the negative infinity power. On the bottom we have 15 minus 16 times negative infinity. And we notice something on the top, that we have a negative exponent right here because it was negative infinity. So what that does to this problem is it puts positive infinity, or excuse me, let me erase that. It puts 1 over 2 to the infinity power, and then the denominator still has our 15, and we have a negative 16 times the negative infinity. So it turns out that that becomes positive infinity. Okay, so evaluating the 5, we can't do anything with that. But this, 1 divided by 2 raised to the infinity power, 1 divided by a very large number, 0. So we have 5 on the top. And on the bottom we have 15 plus infinity. Well, that's just infinity. So what is 5 divided by a very large number? And the answer is positive infinity. So that takes care of that one. Number 16 is a direct substitution problem because it's just a straight polynomial. And so you look at the highest exponent value, and it's this negative 6x to the third power. So that's the one that's going to gain the most value the quickest. So that's what's going to determine the end behavior at negative infinity. So if we just plug in negative infinity to the third power, so we have a negative raised to the third power, which is a negative large number, and we multiply it by this negative 6 coefficient, and that turns out to be a positive 6 times infinity. Well, that's just infinity. So that limit as x goes to negative infinity of that function is positive infinity. Okay, number 17. It's asking us, where is this function discontinuous? Well, the bottom, the denominator, is already factored. So we're asking ourselves, it becomes discontinuous where it's undefined in the denominator. So what causes that to go to 0? There's two cases. If x equals 0, the entire denominator would equal 0. In fact, it would look like this. 0, if you plug in 0 for x, you get 0 minus 3 on top, and you get 0 times 0 plus 9 squared, and of course that would equal a negative 3 divided by 0 times 81, which, whoops, that's undefined because you end up with negative 3 over 0. So we know that at x equals 0 it's discontinuous, and we'll speed this other one up a little bit. We set the other part of the denominator, the factored portion, x plus 9, set that equal to 0. X plus 9 squared equal to 0, and take the square root of both sides, and there you have it. The square root cancels out. The square root of 0 is 0, so you have x plus 9 equals 0. So it's also discontinuous when the value of x is equal to negative 9. Okay, we'll go ahead and post this one, and we'll try another one.